So we're now going to look at how to program a simple numerical multi-part question in Stack. Okay, so before programming the question, it's a good idea to carefully plan out the question you want to ask and what types of answers you want to accept from students. So let's have a look at a fairly simple question. Let's consider the question: a square has a side of length. Now I want a range of variables here, so let's define this as L, and we'll call that centimeters, and say I want this to be between 5 and 9.99 centimeters, and I want these displayed with 2 decimal places. And then I'll ask 2 questions about this. In the first part, I'll ask what is the area of the square, and obviously my answer to that one is going to be L squared. And then I'll also ask what is the area of, and we'll give them an integer here, so integer n of these squares. And clearly the answer to that is NL squared. But we may want to give them marks for this second part if they have some answer to the first part and they do n times the answer to the first part as well. So we'll accept either this answer or this answer as correct. So how we're going to do that in Stack is that there's going to be nodes. So first of all, we'll check if the student's answer is the same as n times answer 1. If it is, then we'll give them the marks. If it's not, then we'll go on to the second node and check, is it equal to NL squared? If it is, we'll give them the marks again. So possibly they got part 1 incorrect, but they calculated part 2 correctly and put in NL squared. So now that we've planned out what we want to do, let's have a look at Stack and see how we can actually get it to do this. Okay, so now we've planned out what we want in our question. Let's write it into the quiz. So I'm on my new quiz and I'm going to add a new question, and I select a Stack type question. Now I'll need to give my question a name, so let's call it the square question. So I find it easiest to do all my calculations in the question variables box. So if you've done any programming before, this will be fairly straightforward for you. So I'm using L for the length, so I type L and then colon, and that defines my variable name. And now I need to say what that variable is. So it's floating. So I put float and then 5.00, and then I wanted it to be between 5.00 and 9.99. So I can use rand to generate a random number. So I can put 5.00 plus rand, and then I'll generate a random number between 1 and 1,000 by putting 1,000 in brackets there. And then if I divide this by 200, that will get me a total number between 5 and 9.99. And then I can put a semicolon. The semicolon isn't absolutely needed, but it helps to keep it a bit neater. And then I also need a integer for n, and so I'll say this is a random number between 1 and 20. And then in physics, I care a lot about significant figures and decimal places, which you possibly don't care as much about. So feel free to ignore this next step if it's not relevant for you. But I'm going to have a new variable, display L, which is the variable which will be displayed in the question that the students will see. So I'm going to use dn, which tells it how many decimal places to use, and this is going to be L, this variable, but displayed with 2 decimal places. I'm going to do the same thing to my integer just to absolutely ensure that it shows up as an integer. So, oh, silly autocorrect. So display n, and we'll just put this. So n with 0 decimal places. And now you can just put your answers down the bottom, but I find it easier to do the calculations up here. So I'm now going to define my area, which is what I'm asking for in the first part of the question, as L squared. And then I will want to display the answer to the students at some point. And in physics, we tell them to always display it with the same number of significant figures as was used in the question, which in this case, the length is given with 3 significant figures. So I'm going to just make sure that my answer shows up with 3 significant figures. So I'm going to label this A1. And then I type significant figures. Oh, it's auto-corrected again, get rid of that. And we'll want area, and it's given to 3 significant figures. You don't have to do this significant figures thing if that's not important in your area. And then in the second part, I'll call my correct answer to that n area, because it was n times the area. We don't want to autocorrect. So that variable is defined as n times L squared. So in stack, you need to make sure that you always include the times, even before an open bracket. It doesn't assume that there's a time sign there. And then our second answer, again, we want it to 3 significant figures. So let's copy this from up here. And it's n area to 3 significant figures. Okay, now random group, that's not important. You can almost always ignore that. So this writing down here is important. We'll worry about what it does later, but definitely don't delete it. Okay, so let's call this square question. If I write this here, the question name will appear to the students. Okay, so the text we had was a square has a side length of, now stack uses latex, so if you're comfortable with latex, this can make everything look a little bit nicer. So I'm going to enter latex, and then I'll put L is equal to, and then what I want to do is enter the variable which was defined up here, my display L. So in order to get it to pass the number from the variables into the question, what I need to do is open curly brackets at, and then I will do my display L, and then I need to stop that, so at, close that brackets, and then I'm going to end my latex, so that's ended latex, and then I need to include my units, so I'll put centimeters. Okay, and then the first part is what is the area of the square. Okay, and now we're going to want the students to answer. This input answer will be where their answer appears. So let's set it up nicely for them. Let's put area is equal to this, and then I'll put centimeters, and I can put squared, or I could have put that in latex if I wanted to. So this will input answer 1, and then the validation answer 1. This will display that answer to the students just beneath this part of the question. So it's nice to have the validation close to the input. Okay, now we're going to have the next part of the question. What is the area of, and now we're entering our integer from up here. So again, let's do that in latex. So n is equal to, and then pass display n down, and then end latex of these squares. Okay, and then we'll want them to input their answer. So let's copy that from up here. except that now it's number 2 and validation for answer 2. Okay, so default mark 1, that's fine. Penalty, I usually go with a 33% penalty. So if they get it wrong on the first try, they lose a third of the marks, but then they can keep on trying. Now, question note, this is needed when you're using random variables because L and N both use random variables. I'm going to have to put @L here and also @N here. Okay, so now I want to save changes because that's going to make it realize that I've actually got 2 input answers here. So let's go save and continue editing. Okay, so you can see now it's realized there's 2 parts. So now I've got input answer 1 and input answer 2. Okay, now the questions I'm showing you this time are numerical. So we'll have a numerical answer, and my model answer was set up here. I had it displayed with 3 significant figures. So A1 is this model answer, which is what will get displayed to students when they go back and check it and it says the correct answer is blah. This is what will be displayed there. Okay, and for the second part, it was A2. And we can just ignore everything else there. Okay, so now we need to set up our different parts. Because we're doing numeric ones here, let's do num relative. So with the relative, it means with the test options, if I put 0.03 here, this will mark them correct if they are within 3% of the correct answer. And there's other options as well. We could do num, sig, figs, or any of these num ones to check. But I find num relative is fairly good. Okay, so we want it to be quiet. Just always set quiet to yes. If quiet is set to no, then when you have really long response chains, which we don't have in this question, it will display every kind of node, the feedback from every node to the students, which is occasionally what you want, but not usually what I want for my questions. Okay, so the student answer, we're going to call their answer answer 1. And what it's going to do is check the student's answer against the teacher's answer. And the teacher's answer was we asked them to calculate the area, and the area has been defined up here. So we are going to put area here. And then if answer 1 is the same as area, they will get the marks. So we can give them feedback if they get that correct. So you have answered correctly. And then we can also give them feedback if they answer incorrectly. So if they answer incorrectly, we probably want to tell them how to calculate it. So the area of a square is given by, and then let's enter latex, L squared. So now they know how to enter the answer. Okay, so let's save these and continue editing. Okay, so I've now got my input for answer 2, but I don't have my potential response tree for part 2. So to get that, I'm going to have to go up to this specific feedback and add that for part 2. So make this part 2. And then if I go save changes and continue editing, it brings up my response tree for part 2. Now the response tree for part 2 was a bit more complicated because we wanted to mark them correct for 2 answers. If they did n times the answer they had to the first part, they should be marked correct, and also if they get the correct answer, so nl squared. So what we'll want to do is add another node. So we click add another node and then it reloads. Okay, so again, these are numeric answers. So let's go with number relative, and I'll go with 3%, 0.03, and I'll keep this quiet. And we're calling the student's answer answer 2. And first of all, we'll check if this was the same as n times their previous answer, which up here we called their student answer answer 1. So if they've entered for this answer n times answer 1, we want to mark them correct. So that will stop at that point, and we can say you have answered this correctly. Now, if they get it incorrect, then it'll go onto this box, at which point we want to send them down to node 2 to check if they somehow got part 2 right without getting part 1 right. So again, it's a number, so we'll put num relative and 0.03, and yes, we want it to be quiet. Their answer is still called answer 2, but this time we want to check it up against n squared, n times L squared, which we called n area at the top. Okay, so if they get it right this way, we want to give them full marks as well. You can give them partial marks if you've got a preferred way that they do it. So here we can put you are correct. And if they get it incorrect, then we should give them some feedback. So you need to multiply the area calculated in the first part by n. Okay, so let's save these changes. Okay, now what you can probably do is preview it here. So this will just make sure that it displays correctly. Something has gone funny here, so we should go look in and see what we did wrong there. So this should have been display decimal places, so DP, not DN. So let's check that that looks right. Okay, so let's check it again. Okay, so let's enter an incorrect answer for this first one, 10. That's clearly not 9.68 squared. But then let's check that we've programmed this correctly by doing 7 times 10 and seeing if it marks us as correct. So when we check that, you can see we get the first mark incorrect, so your answer is partially correct. The area of a square is given by L squared, so it's telling us what we need to do there. And then for the second part, we've answered correctly. So let's just try again. Let's now try answering it correctly. So 9.09 squared gives us 82.6. And then if we okay, so that's clearly an issue. It's saying that this is invalid when we've entered it as a floating point, which isn't what we want it to do. So we just need to go through to our settings here. And our input for answer 1, here where it says forbid floating point, no, we don't want to forbid floating point, and we better do the same thing for answer 2. Okay, so save it. And then we'll try again. Okay, so 9.28 gives us 86.1. And then we want to multiply this by 14 and we get 1,205. So let's put that as 1,200 and just check that there's enough tolerance built in to mark that as correct. So it's now telling us that we've answered both of these parts correctly. So hopefully that gives you some idea how to build a fairly simple numerical question in Stack.